Hello, and welcome to Introductory Probability. To begin, let's think about the relationship between questions and answers. For example, I might ask you what's 2 plus 2, and the answer is clearly 4. Or what's the capital of Romania, and you might say Bucharest. If we wanted to capture questions like these formally, we might use functions. Functions have the property that a given question has a distinct single answer. 2 plus 2 is always 4, triangles will always have 3 sides, and if I repeat a question, that answer isn't going to change. So what about questions that aren't so clear-cut? What's going to happen after I roll this die? Is there a single definitive answer? No, because the answer might change each time we ask the question, or in this case, each time the experiment occurs. So how might we begin expressing questions like this formally? Well, first we should consider what are all the possible things that can happen in our experiment. This complete set of outcomes is known as the sample space. We might not know what will happen, but after our experiment, we know one of these things must happen. So how do we express questions that might have changing outcomes? Well, all we can really say is that anything might happen, but individual outcomes might happen more or less often than other outcomes. For example, maybe when I roll this die, the outcome tends to be even numbers more often than odd numbers, or maybe no outcome is more likely than any other. So how might we capture this? Well, first let's rearrange our possible outcomes and take out our stick of probability. The rules of this stick are simple. It has a length of 1, can be broken up into pieces, and those pieces must be distributed among the outcomes. If an outcome has all of the probability stick, then this outcome will definitely happen. And if an outcome doesn't have any, then it definitely won't happen. Here we might capture the case where even numbers are more likely and we can see that they have bigger pieces of the probability stick. Or here, where all outcomes are equally likely, as is common in a real-world die. The length values can easily be transformed into percentages, and we can see all of these outcomes have a 16.7% chance of occurring.